special control schemes that is called the cascade control. Cascade control. Cascade control means it has two loops, multi-loop or multi-loop control technique, multi-loop control technique. One of the multi-loop control techniques is cascade control. It has two loops, inner loop and outer loop. Inner loop and outer loop. Inner loop and outer loop. For this case, we have to separate the process into two parts. That is G1, G2. For example, in a level process, if you consider the level process consists of flow process also. Am I correct or not? Level process consists of flow process also. Flow process only gives input to the level process. If you consider that the flow rate alone, it is a flow process. So here G1 is, if you consider a level process, G1 is a flow process. G2 is level. If you can separate the level process into two parts, one is flow and the level. Flow rate and the level. Actually, flow rate and level. We are going to control flow rate as well as level. Why? That we will see now. What is the need for cascade control? First we will see. Then what is the need for cascade control? I'm having a level process. I'm having a level process. Level transmitter is there. The level transmitter output is given to level controller, that is PID controller. Set point is given here. The output of it is level controller. Regulates output of this valve regulates the input to the level process. Here, the flow rate is function of the flow rate is function of valve opening M. Valve opening we used to say M. Valve opening M. Upstream pressure we can say it is PI, upstream pressure, or UI, upstream pressure, UI, as well as downstream pressure. But downstream pressure is in this case open to atmosphere, that's why it is constant. But upstream pressure may change. Now let us assume that the process is at steady state. The process is at steady state. Is at steady state. It means set point equal to PV. Set point equal to PV. That time the upstream pressure decreases. There is no change in valve opening. There is no change in valve opening. Upstream pressure decreases. That's why there will be a decrease in flow rate. Decrease in flow rate. Because of decrease in flow rate, level will decrease. Because of decrease in flow rate, level will decrease. As level decreases, the level transmitter noted that decrease in level and it takes appropriate action to open the valve more. Why it opened the valve more? Because of the disturbance in the flow process. Valve is, there is no other disturbance. Disturbance is in the upstream pressure only. Upstream pressure decreases, that's why flow rate decreases. The level transmitter noted the decrease in level because there is a decrease in inflow rate. Therefore, the level controller takes necessary action to open the valve more. Now it adjusts the level to bring back the level to normal level, nominal level. This is the level controller in single loop. Instead, suppose I am having one more loop that controls flow alone. That controls flow alone. One more loop I am putting. If any decrease in flow rate means immediately it adjusts the flow rate to nominal flow rate. That's why the level will not decrease. The level will not be disturbed that much. Now what is happening? Stream pressure decreases. That's why flow rate decreases. As flow rate decreases, level decreases. Once the level decreases, then only the level transmitter noted. It is conveyed to controller. The controller takes necessary action. Now the valve is opened more. Therefore, the level is bring back again. Takes long time. Because time constant of level process is large, but time constant of flow process is very small. I am doing this way. I am monitoring the flow rate. Set point equal to PV. I am noting down the flow rate now. If any change in flow rate is there, then and there I am adjusting the valve to regain the original flow rate means. Will it there any level change? No, because I am adjusting the flow rate. Instead of adjusting after level deviated, taking necessary action, I am taking action whenever there is a change in flow rate. If we are able to do that, there will be a better control we'll get because flow rate process is very fast. That's why it will not create that much deviation in level. Before that, the flow itself adjusted again to original value. For that, we can go for cascade control. How it can be implemented, that we'll see now. How to implement cascade control in the level process. For that, we need two controllers required. One is for flow rate. For that, we have to measure the flow rate. We have to measure the flow rate as well as level. The level also has to be measured because we are interested in level. Are we interested in flow rate? No. Our interest is not in flow rate. Our interest is level transmitter only, but it takes long time if you use single loop. That's why we are going for two loop controller. So level is measured. Level output is given to level controller, one PID controller, level controller. Set point is given. Here, the output of this level controller, instead of giving valve opening, it gives how much flow rate it must have. Suppose let us assume that level is 50%. What should be the flow rate? 50%. Therefore, the controller output is 50%. Controller output is 50%. That will be taken as set point for level flow controller. Set point for flow controller. Another flow controller I am putting. It says level is 50%. Required flow rate is 50%. That is given as set point to the flow controller. Actual flow rate is measured here and it is compared with that. If the level is 50%, flow rate must be 50%. Cross variable 2. This is cross variable 1. Primary variable is cross variable 1. So flow rate is measured here. If any deviation happen, it will adjust to the valve. Now, what will happen? Now, if you see, let us assume that now set point equal to PV. Set point equal to PV. Set point 1 equal to PV1. That is level is at its set point. That time there is a decrease in upstream pressure. Upstream pressure decreases. What will happen to the flow rate? Now, what is the flow rate? 50%. Flow rate is 50%. Set point is 50%. Flow rate is 50%. But upstream pressure suddenly decreases. That's why flow rate decreases to 48%. Flow rate decreases. That's why this flow controller noticed the change in flow rate. That's why it will adjust the valve opening more. And again, flow rate is come again to 50%. Even though the upstream pressure changes, the flow process is the fast process that adjusts immediately that flow rate. Therefore, the deviation in the level is avoided. Are you able to understand what I am saying? But anyhow, small deviation will be there, not that much. A small deviation will be there, not that much. If a single loop controller means change in upstream pressure, that's why there is a decrease in flow rate. Because of decrease in flow rate, there is a change in level. The change in level is noticed by level transmitter. Then level controller controls the valve directly. But here it is not so. As soon as change in upstream pressure, there is a change in flow rate. Flow rate is measured then and there. This flow transmitter, this is the flow transmitter, DPT, flow transmitter, that gives to flow controller. This primary controller gives set point, not the control output, to the secondary controller. This controller is called secondary controller. Secondary controller. It gives set point to the secondary controller. That's why in the electronic PID controller, while configuring, you can give set point from another process. Suppose you want to use a cascade control, means 2 PID controller you have to use. For level, you will use 1 PID controller, as we have seen. In that, we will give set point. Here, the secondary controller, set point is given by primary controller. So here also, the set point will be 4 to 20 milliamps. Set point will be 4 to 20 milliamps will be given as set point to that. That's why there is one option called, it is a primary controller or secondary controller. If you put secondary controller, we have to give set point also as input 4 to 20 milliamps. 4 to 20 milliamps we have to give. One for PV, another one for set point. So it will ask, are you going to use it as a primary controller or secondary controller? If you are using a cascade control. So the secondary loop, this loop is called a secondary loop. Secondary loop. This is primary loop. If you draw the conventional diagram, it will be like this. I will draw here. This is set point 1. This is given to the primary controller. We will call it as controller C primary. Outer loop controller C primary. It gives set point 2 to the secondary controller. Here, this is CP secondary, controller secondary. Its output is given to the process. One process is separated into 2 parts. Process is separated into 2 parts. This is process 1 and the process 2 is there. Process 2 is there. It's the process flow rate is measured here and given to the secondary controller. The level is given by this primary process variable. This gives PV1. This gives PV2. Let us call, that's why this is P2, this is P1. So what is the requirement here? We should be able to measure the output of if we separate the process in 2 parts, we should be able to measure the input to the primary process. Then only we can implement. The secondary variable, there must be a provision to measure the secondary variable. Then only we can implement. I'll draw here. so that you will get, you can draw set point 1. It outputs is given to primary controller. Its output is a set point 2 that is given to secondary controller. Secondary controller. Its output is given to flow process. In this case, it is given to flow process or secondary process. That is G2 or G1. It is given to primary process. This is primary process, G2. That is, in this case, it is level. This is primary process variable. Here, secondary variable has to be measured and give it as a feedback. This is secondary controller. Primary variable is measured here and give it as a feedback here. This is inner loop. That's why it is called inner loop. This is called outer loop. This is called secondary loop. This is called primary loop. This is called primary loop. This is called cascade control. So we can improve the speed of response by using cascade control. We can improve the response by cascade control. If you put cascade control, we can improve. But here, for this flow process, what type of controller here we have to put here? What type of mode we have to operate for flow process? P or P plus I or P plus I plus D. What type of controller we require? For secondary. Primary, we are going to use, P plus I because I want a tight control on level. That's why I'm going to use P plus I. It is not a thermal process. That's why I'm going to use P plus I. For flow process, what type of process I have to use? P or P plus I plus or P plus I plus D. I'm going to use P only because there is no need to have tight control. We have to increase the speed of response so that it has to quickly control. That's all. No need to have set point equal to PV. No need to have set point equal to PV. The set point of primary controller need not be equal to PV2. This is set point 2. Need not be equal to PV2. That is not our requirement. But it should be speed up. The control should be speed up. That's why P only is sufficient. Speed. I mode means it will take time. It will introduce delay. That's why there is no need to have I mode that will introduce delay in the process. At the same time, no need to have PV2 equal to SP2. Only thing is I have to speed up the response. That's all. There may be a difference. What is that? Steady state error may be there. But the level should be controlled quickly. That's why we are putting only P only controller. That's why the flow process here, it will be a P only. But level process is P plus I. Level process will be P plus I. Suppose this is, on the other hand, suppose I'm having another thermal process. Already we have seen this type of thermal process already. Exothermic process. That's why a coolant is entering here. The coolant takes away the heat. It is a temperature process. How a cascade control can be implemented here, that we will see now. The coolant flow rate is F0, coolant FC. The coolant outlet temperature, that is FC, TCI. The coolant is entering here. It takes away the heat. We have to control the temperature of this thermal process. Here feed is coming here, Fi, Ti, inlet temperature is Ti, inlet flow rate is Fi, the outlet flow rate is coming here, that is T, outlet temperature is T, outflow rate is F0, process outflow rate is F0. Let us assume that there is no change in Ti, there is no change in Fi. If any change in Ti or Fi happens, there will be a change in T. Am I correct or not? If any change in Ti, inlet temperature changes, T will change. I am interested in controlling T. I am interested in controlling T. T is the primary variable. For better quality of the product, T should be maintained constant. If Ti changes, T will change. Fi changes, T will change. If TCI changes, T will change. Am I correct or not? Coolant temperature changes, T will change. Flow rate, FC changes, TCI will change. Suppose TCI changes, let us assume. Inlet temperature of cold water changes. That will I'm having a temperature transmitter that measures temperature. That is given to temperature controller. Set point is given to the temperature controller. That will regulate the cold water flow rate only. If temperature increases, it will increase the flow rate. If temperature decreases, it will decrease the cold. Whatever may be the disturbance, the disturbance may be entered because of Fi or Ti or FC or TCI. Disturbance may be entered because of any one of these disturbances. But when it will control, whenever T deviates, then only it will control. Whenever T deviates, then only it will control. So, suppose inlet temperature of cold water changes. Let us assume that inlet temperature of cold water changes, then also T changes. That time, if you put one more controller for cold water temperature, suppose you are putting one more controller for cold water temperature, if it often changes, that's why I put a more controller, then whenever cold water flow temperature changes, it will increase the cold water flow rate or decrease the cold water flow rate to control then and there, so that it will not affect T. It will not affect T. Suppose often in this process, cold water flow rate changes, let us assume. That's why I am putting one more controller for cold water flow rate. If cold water flow rate changes, immediately one more controller takes necessary action to adjust the cold water flow rate, means it will not affect the T. It will not affect the T. That way we can put, that is called cascade control. For that, what we have to do is, instead of having this directly controls this, we have to put one more controller, that is called flow controller. The set point is, the temperature controller gives set point 2. This is set point 1. The flow rate is measured here. And it is given as PV2. And the flow controller regulates the valve. Now, whenever any change in flow rate is, then and there noticed, immediately it is correct, because flow rate is very fast process. That's why it will not deviate the temperature. This is another example for cascade control. Another example for cascade control. We'll how to implement this on lab, that we'll see in the next class.